Section 1.3 is about solving equations. There's a lot of things in this section that are fairly basic and fundamental. We're going to get through those, and you're going to find a lot of it to be a review. Here we're asked to write an algebraic expression for these verbal expressions. Algebraic means we're going to write this using algebra, numbers and letters. 7 less than a number means I'm going to start with a number and subtract 7 from it. That's what less than means. It means you're going to take 7 off the number that already is there. The next one says 3 times the square, so I'm going to multiply the square of a number. When you take a number and don't know what it is, and you square it, you use an exponent. So that's what 3 times the square of a number is. There's other ways that you could write that. You could put a dot, you could put parentheses, so there's a couple answers there. In this one it says the cube of a number, so I'm going to pick a letter that I don't know, because it's called a number, and I'm going to take the cube of that increased by. Increased means I'm going to add, and then I'm going to say 4 times the same number. So that's an algebraic expression of that verbal expression. And then the last one, twice. Twice something means 2 times something. Now when it says the word sum, don't forget that there's 4 key words when talking about verbal expressions. There's sum, difference, product, and quotient. And if you remember, sum is an addition, subtraction is the word difference, product means multiplication, and quotient means division. So when I see the word sum, that means I'm going to use parentheses because the next thing inside the parentheses is going to be an addition problem. So the sum of a number and 5. Remember, when you see a word like sum, you look for the word and the and's going to tell you where the addition sign goes. An open sentence is a mathematical sentence that contains one or more variables. So something like 2 plus 3 would not be considered an open sentence, but 2 plus x would, because part of it is a variable. An equation is when that sentence has an equal sign, has 2 expressions that are equal. So you could say 2 plus x equals 5. That's an example of an equation. Here we have 3 equations, and we want to write in words. We want to write the verbal sentence that represents these equations. Basically, you just want to write down how you would read these equations. So this first one looks like we could say 10. We could say is, or we could say is equal to, or just 10 equals 12 minus 2. You could also say the difference of 12 and 2, 12 take away 2, lots of ways you could do that. The second one, we could say the sum, because we're using addition, the sum of a number, that would represent the letter M, the sum of a number and negative 8. And then we would say is means equal to negative 9. So that would be a sentence we could use there. We could also say n plus negative 8 is equal to, a couple ways to do that. And in this one, we could use quotient of n and 6, but I'm just going to say n divided by 6, or actually better, I'm going to say a number divided by 6 is equal to the number squared, or you could say to the second power. Here we're defining what a solution is. A solution is a replacement value for a variable that makes an open sentence true. X plus 2 equals 5. That's an open sentence, and so the solution is the number that I could put in here that would make this true. So we can tell by looking at this that x should equal 3. That is my solution. There is no other number that would be a solution of this open sentence. Here we have more properties that make up the building blocks of algebra. The reflexive property says if one side of an equation is something, then the other side equals exactly the same thing. That's the reflexive property. It's like looking in a mirror. The word that I think of is reflection. So the left side equals the right side exactly. The symmetric property says the left side and the right side are equal, but they don't have to look exactly alike. The example over here is 3 equals 5x minus 6. We know that those two sides are equal to each other, but we can flip it too. We can make it 5x minus 6 equals 3, and it remains the same equation. That's the symmetric property. Transitive says that if you have a first and a second value that are equal, the second value equal to a third value, that you can then make the statement that the first and the third value have to be equal. That's the transitive property. And then substitution is the property that's used probably most often. It's simply a property that says you can replace one equal quantity with another. Over here you see an example, 4 plus 5, since that equals 9, you can replace that. You can replace the 4 plus a 5 with a 9. So let's see if we can figure out these two examples of properties. Here 3m equals 5n and 5n equals 10p. Therefore we can say that the first and the third are equal. That is the transitive property. And the second one, we have an equation, negative 11a plus 2 equals negative 3a. And then we switch it. Negative 3a equals negative 11a plus 2. You got to be careful. Some people might say that this is the reflexive property, but these two sides of the equation are not exactly the same. All we've done is flipped the sides, and that's the symmetric property. Here we have the properties of equality, which are super important if you're trying to solve an equation. Basically what they're saying is that you can add and subtract a number from both sides of an equation, and the equation remains equal. And then the one down here, the multiplication and division property, says that you can multiply and divide both sides of an equation, and that's legal to keep the equation equal. It's like balancing the scales. An equation has to remain balanced. The left side and the right side have to constantly be the same. So whatever you do to the left side, you also have to do to the right side in an equation. Let's illustrate that here with some examples. I want to isolate this a, or isolate this unknown. So I'm going to subtract 4.39 to get the a by itself. But whatever you do to one side of the equation, you have to do to the other side. So we'll subtract 4.39 from the other side. And 76 minus 4.39 is 7161. So we've isolated our a, and we've now solved it using the subtraction property of equality. Here you see a d that's connected to a negative 3/5. With multiplication, typically we're going to divide both sides by negative 3/5. So we cancel those off. Now this one's a little different because if we have the number 18, and I'm going to write it as 18 over 1, and we divide that by a fraction, the other way to think about that is by multiplying by its reciprocal. If you remember, we can take the number negative 3/5 and we can multiply by its reciprocal, negative 5/3, and we can solve this over here. 3 and 18 will cancel, leaving us 6. 6 times negative 5 is negative 30. So technically what we did is we used the division property of equality because we divided, but then we used a little trick of multiplying by the reciprocal to solve it. Here we have an equation that we're going to use to review lots of techniques for solving an equation. We have parentheses that we're going to have to get rid of by distributing. So 4x plus 6 will distribute the negative 3. Be careful that you include the negative sign with the 3, which makes this a negative 12x and a positive 15, and then it equals 22. You have like terms that are on the same side. This is how I like to deal with them. I put a box around them or something, and I know that I'm going to collect 4x minus 12x. Well, 4 minus 12 is negative 8, so we have negative 8x's. And then I also see like terms that are on the same side, so I'm going to collect them. 6 and 15 is 21. And now I have an equation that I should be used to solving. I'm going to isolate the unknown. We do PEMDAS in reverse. So instead of doing multiplication and division first, we deal with the addition and subtraction. So we're going to subtract 21 from both sides to keep the equations balanced. So negative 8x equals 1. And then finally, the negative 8 is connected with multiplication. So I'm going to do the opposite operation to cancel it, which means I'm going to divide by negative 8. And therefore, solving this, x equals negative 1/8. Our last slide here has a geometric formula right here. And we're given some information about the formula, and we're asked to solve this formula for L, which means L becomes the letter that I want to isolate. I have to get everything else away from the L, even if it's another variable. So how can I do that using algebra? Well, I'm adding a pi r squared, so according to the rules of algebra, I can subtract that from both sides. and cancel it off over there. Now s minus pi r squared, those are not like terms, so the best I can do is just rewrite it as s minus pi r squared equals pi l. Now remember, we're trying to solve for the L, so how do we get rid of a pi that's being multiplied? Well, we're going to divide both sides by it. So the pi's will cancel. I'm going to rewrite this with the L on the left. S minus pi r squared over pi. That's what the formula would look like. Please avoid the temptation to cancel the pi's. You can't do that because the pi is part of the s minus pi r squared, so you can't take a piece of it. So here's what the formula looks like solved for L.